All right, we're starting the second trig unit, and we're starting with coterminal angles. This is actually a concept that's come up before. We just haven't used this terminology. Coterminal angles are angles with different measurements that have the same terminal side. So if you remember on a unit circle, when we make an angle or we do a rotation, we always have an initial side, and the initial side is always on the positive side of the x-axis. So all of our angles that we measure using the unit circle are aligned, so they start here on the positive side of the x-axis. Then we have another side called the terminal side of the angle, and that's the side that determines the sine, the cosine, and tangent. It's where that side intersects the circle. So this angle I drew right now is, I'm going to say it's 135 degrees. If we do that in radians, that would be 3 pi over 4. And I got that angle by drawing my initial side on the x-axis and by rotating not quite halfway around the circle. And that gave me 135 degrees. And if I wanted to, I could find the coordinates of this point and get my sine, cosine, and tangent. I'm going to jot that down really quick. This lesson, you're not really going to have to worry about finding sine, cosine, and tangent, but that will come in play as we go forward with this stuff. So I do want you to kind of keep that in mind as we're doing this. So the sine at this point is square root of 2 over 2. The cosine here is negative square root of 2 over 2. And the tangent, sine divided by cosine, is going to be negative 1. So the sine, cosine, and the tangent at that point we've got listed there. So that's one way I can get to that point and get that sine, that cosine, and that tangent. But it's not the only way. One thing we've talked about and that we noticed when we graph a sine or a cosine function is there's an infinite number of angle measurements or rotation measurements that will get us the exact same sine, cosine, and tangent. So the question is, how do we get more of them? Well, there's a couple ways to do it. The quickest way is to just go around the circle again. So for this first angle, like I said, I started at the x-axis and I went not quite halfway around the circle and stopped. But what if I kept going, go all the way around, back to the starting point, and then keep going again until I get to this same terminal side? And that's still an angle that has the same initial side and the same terminal side. But this time, instead of going 135 degrees, I went 495 degrees. I went all the way around the circle and then continued going until I got to that same terminal side. And in radians, that's 11 pi over 4. So examples of coterminal angles is 135 degrees and 495 degrees. Those are coterminal angles. They are different angle measurements, but they have the exact same sine, cosine, and tangent, and they put you at the exact same spot on the unit circle. The other way you can get coterminal angles is to go negative, to go backwards. So both of the angles I drew so far, we went counterclockwise around the circle, and we know that's the positive direction. Then we could also go counterclockwise. We could start at the same initial side that we always start at and go clockwise and end up at this same spot, this same terminal side. And if you do that, you have to go a little bit further than you do when you go in the positive direction, and you actually go negative 225 degrees. Or if you do radians, that would be negative 5 pi over 4. So you could say that 3 pi over 4, 11 pi over 4, and negative 5 pi over 4 are all coterminal angles. They all put you at the same spot. And I can add negative 225 to my list of degree measurements as well. So that's what we're looking at here. And so the way you do this, the quick way to do this, and you may have already kind of caught this, is to just add or subtract one full rotation. So whenever you have an angle to start with, like let's say we're starting with a 55 degree angle. If I want to find a coterminal angle, I can do that by just adding 360 degrees to it. So if I take 55 and add 360, that is going to give me 415 degrees, which will be another angle that puts me at the same spot at the unit circle and has the same sine, cosine, and tangent as 55. The other way I can do that is by subtracting. I can take 55 minus 360. And if you work this out by hand, the way I think through things like this when I'm subtracting a bigger number is I just take 360 minus 55 and then make my result negative. So I get negative 305 degrees. So those angles are all coterminal, and you get those angles by adding or subtracting one full rotation. So in degrees, that's 360. In radians, that is 2 pi. So that does get slightly more complicated, even though it's the same concept. Here we go, I'll do purple. So say I have an angle that is 4 pi over 3. Well, let's do 4 pi over 7 radians. That's my angle, and I want to find a coterminal angle. Well, I have to subtract or add one full rotation. So for radians, that's 2 pi. So if I take 4 pi over 7 and add 2 pi, what I need to do is make 2 pi into a fraction with a denominator of 7. So that's going to become 14 pi over 7. And then I add those together, I get 18 pi over 7. So that's a coterminal angle. And I can do the same thing by subtracting 2 pi. So if I'll do this over here, it'll kind of intersect with the circle, but hopefully you can still see it pretty well. If I take 4 pi over 7 minus 2 pi, same thing, 4 pi over 7 minus 14 pi over 7. And when I do that, I'm going to get negative 10 pi over 7. So that's what you're doing here, is you're finding equivalent angles with the same sine, cosine, and tangent that put you at the same spot in the circle by adding or subtracting one full rotation, which is 360 degrees or 2 pi radians. So a few more examples here. This is what your assignment is going to look like. It says find 2 positive and 2 negative angles that are coterminal with each of the following angles. So all you need to do for this assignment, and I don't think we're going to do all 3 examples because I think you'll get the point. Start with the angle they give you, so 25. Add 360 to it. That gives you one coterminal angle, so 385 degrees. And then add 360 again, and that will give you another positive coterminal angle, 745 degrees. Then do the same thing with subtraction. Take 25 minus 360. So again, I write that as 360 minus 25 and then make my answer negative. So I get negative 335 degrees. And then subtract 360 again. And when you have a negative minus a negative, the easiest way to do that, I think, is just add the numbers together and make your result negative. So you get negative 695 degrees. So really, you're just adding 360 twice, subtracting 360 twice. We can do the same thing with 140. When you add 360, you're going to get 500 degrees. And when you add 360 a second time, you will get 860 degrees. When you subtract 360, you're going to get negative 220 degrees. When you do that again, you're going to get negative 580 degrees. So one thing I do want you to notice about a positive and negative coterminal angles, and I'm going to get a different color here so you can see this. If you have a positive angle and you take the first negative coterminal angle, so here for 25, that would be the negative 335. If you add the absolute values of those angles together, you should always get 360. Because they should, when you put them together, make one full rotation around the circle. Because the idea is one of them is going clockwise, One of them is going counterclockwise, but they meet in the same spot. So together they make one full rotation. So same thing with 140 and negative 220. If you take the absolute values and add them together, you get 360. Let's do the same thing with radians. Radians slightly more complicated, but it's really just the same idea. We have 2 pi over 5, and we want to get some positive and negative coterminal angles. So I need to add 2 pi to 2 pi over 5. And again, I have to make 2 pi into a fraction with a denominator of 5. So that's going to be 10 pi over 5. So I'm going to get 12 pi over 5 as my first coterminal angle. If I add 10 pi over 5 again, 10 plus 12 is going to give me 22 pi over 5. To get my negative ones, I'm going to have 2 pi over 5 minus 2 pi, or minus 10 pi over 5. That would give me negative 8 pi over 5. And if I subtract 10 pi again, or 10 pi over 5 again, I'm sorry, then I will get negative 18 pi over 5. We'll go ahead and do one more. We have pi over 3. So pi over 3, to add 2 pi, that's going to be 6 pi over 3. So we add that, we get 7 pi over 3. And once you got your fraction down, you can see, well, I'm just adding 6 pi on top every time. The 3 is going to stay the same. So my next angle's got to be 13 pi over 6. Let's do the same thing with subtracting. I'm going to subtract 6 pi over 3. I should get negative 5 pi over 3. And if you're at negative 5 pi and you subtract another 6 pi, that'll put you at negative 11 pi over 3. So same thing as degrees, it's just you're adding and subtracting 2 pi. I just want to show really quick that the same idea I talked about before works here as well. If you take the positive angle and the first negative coterminal angle, so 2 pi over 5, negative 8 pi over 5, if you add together their absolute values, you'll get 10 pi over 5, which is equal to 2 pi. That's one full rotation. Pi over 3 and negative 5 pi over 3, you add their absolute values, you get positive 6 pi over 3, which is equal to 2 pi. One full rotation. So that's coterminal angles. This will be useful in a lot of places. I think, like I said, it already kind of applies to what we did with inverse sine, cosine, and tangent functions, and with graphing, because when you graph a sine or a cosine or a tangent function, it keeps coming back to the same values over and over again. And this is kind of a good, quick way to be able to identify what angles are going to give you the same sine, cosine, and tangent values. So that's coterminal angles.